Okay, the last thing I'm going to do now is just explain to you how to do the inversion of a Z transform. It's cock easy, bro. There's nothing complicated about this. It's literally how you would do the inverse Laplace transform. The only difference is, say they give you, um, oh, first of all, there are actually three methods to do it: expansion into partial fractions, polynomial division, and residue methods. But unless you're a fucking idiot and a suicidal maniac, you're gonna do partial fractions, okay? Don't worry about these other two methods. I mean, residues, I don't even know what the fuck all of this shit means. What is this crap? I don't know, bruh. And then inversion by long division? What? Why would you do this? Just stick to what you know. And that is partial fractions. Cool. Now, all that's happening here is, right? These z variables are expressed as as with positive exponents, and we don't want that because our standard table gives us everything in negative exponents. So what we're gonna do is divide by uh, divide, or really, what's the word I'm looking for here? Yeah, you're gonna divide by the highest order. So that is going to be z over 2 in this instance, right? So it's z over 2 divided by z over 2, that gives you 1. Then it's minus 4z divided by z over 2, that gives you 4 to the negative z, 4z to the negative 1. Then 3 divided by um, z over 2 gives you 3z to the negative 2. And same with the top. Now from here, you can see this is a quadratic equation. So all you do is factorize it into these two terms here. That's when you can do your partial fraction method. Now this here, right? Um, I'll, I'll actually explain this. So this here is just a fast way of evaluating your constant C1 and your constant C1 and C2, and all that's happening is C1 is equal to, I'm only going to do the first one, Z to the negative 1 over 1 minus 3 Z to the minus 1, right? Okay, so this method of evaluating it is something we learned previously, which is it actually comes this comes from doing this. So the limit as z to the negative 1, so you consider the whole z to the negative 1 tends to, so if you are looking for, say, c1, it's going to be the value that'll make this 0, or at least the denominator 0, and that is in this case equal to 1. That'll make it 0. So it's the limit as z tends to 1, multiplied by that denominator that you are making 0, z to the minus 1, multiplied by your original expression, which is this here, right? Z to the minus 1 over 1 minus z over 1 negative 1 over 1 minus z minus 1. Okay, so you can cancel that. That's how you're going to be left with this. Then you're going to input that here. So it's going to be 1 over 1 minus 3 times 1. That gives you negative 1 over. As you Oh shit, I can't count. Amazing. It's two. Oh, and then the exact same thing for this. Then once you've got your component, your constants, plug them in there. Then from here, you use your standard table, and these are this is what your output's going to be in terms of int, not um, not t. It's int now because this is from the z domain. Yeah, that's it.